Okay, so so by the way, just a gentle reminder that the lab class today there will be tests, right? So both theory and lab test will be held in the lab class today. So please join the class meeting, okay, on Teams, and then you will receive your instructions. So you should join sharp at 2. Okay, the test will start maybe slightly later, but you should join sharp at 2 the class because there will be instructions given. Okay,
Sir,
so
nothing
nothing
related to
related
test
to test.
right now, right?
Nothing related to test right now. Yeah.
Okay.
Okay. uh, okay. um, just to recall, what we have been seeing in the last few classes is so we sorry, we have looked at classes. Okay, the C++ feature of class, which allows you to define objects, allows you to define a type, and then you can instantiate class or instantiate objects of that class or of that type using the usual variable declaration method. uh, or you can also, and we have seen that there are various issues related to this particular construction of objects and destruction of objects, okay, in various contexts. So we have seen contexts like situations where the object is being created on stack. We have seen situations where the object is being created on free store using new, and we have seen situations where the object is being created, in a static area. Okay, so in all these cases, uh, in many programs, you may need to do some initialization operations and some finalization operations. Okay, so basically, when the object is before the object is created, you may want something to be done. Okay, and just before the object is destroyed, that is, its memory is freed, some things should be done. Okay, and these two things are achieved in C++ using the constructor and the destructor. Okay, and we have also seen the concept of lifetime of an object. Okay, so broadly, lifetime of the object begins just after the memory has been allocated for that object. Okay, that is just before the execution of the constructor, and it ends just before the deallocation of the memory of that object, which is just till the end of the destructor. Okay, so that is what the lifetime is. Okay, so I hope there are no more questions on this, right? Okay, so now today we discuss some more things about this construction and lifetime, etc. Okay, so so okay, so now one important thing is, so let us look at this particular program. Okay, so 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 we have a class X which has two members. Okay, M1 and M2. Okay, um, and then there is a function which is called init M1, and there's another function which is called init M2. Okay. Um, okay, and basically what they do is, they just they just print M1, the value of M1, and then return M1, and similarly for the other one. Okay, so this is just, so this init M1 and init M2 are just the functions. These are diagnostic functions. Okay, it's not important what the function is doing. Okay, now in the first program to the left, you see so there's the constructor, okay? And what does the constructor do? So the constructor takes two arguments, one for M1, another for M2, okay? And then it basically runs init M1 and initializes the local variable, the class variable, or the variable of this particular object, okay, with M1. Okay, so this is what we are doing here. Okay, this particular code, and similarly for M2. Okay. And then it doesn't do, it just prints, the initial, it just initializes and then it prints constructor or seater. Okay. Okay. Now in the main, we are basically creating this object A of type X. Okay. With M1 is equal to 2 and M2 is equal to 3. Okay. Now look at what is the output. Okay, so the output here is that first you see init M1 2 and then init M2 3 and then ctar and then dtar. So what is happening here? So the first initialization is happening here. Okay, and because this first initialization is calling this init M1 function, so this init M1 thing is getting printed. Okay, then the second initialization is happening. Okay, then this message is getting printed. Then it enters the body of the constructor. Okay, so hence this ctar is printed. Okay, and then after destruction, dtar is printed. Okay, so this program is clear. Now look at the program on the right side. Okay, so it is exactly the same program. Okay, except that the order of the declaration of the data members has been swapped. Okay, so first you so order of definition. So this is definition. So order of definition of data members has been swapped. So the first one is so first you basically define M2 and then you define M1. Okay, so this is what it is. Okay, clear? Nothing else changed. Okay, the order in which you initialize here in the constructor remains the same. Okay, first you initialize M1 using init M1 and then you initialize M2 using init M2. But here you see the order in which the functions init M1 and init M2 get executed has been reversed. Okay, so you are first executing init M2 and then you are executing init M1. Okay, so basically this pertains to the order of initialization of the data members, okay, in the constructor. Okay, so basically the order of initialization of the data members is same as the order in which the data members appear in the class. Okay, so the data member which appears first, which is defined first inside the class definition. Okay, that data member gets initialized first. Okay, and then the next data member gets initialized. Okay, so this is so in this case it is not it is not much, it doesn't matter too much, but look at yeah, so okay, so yeah, so okay, so now look at this string class. Okay, so this is the C style. Yes, you have a question?
Yes, sir. Sir,
Yes.
in the constructor, we wrote like before the braces, we wrote initialization, right? Like M1 underscore of init.
Right. So this we have
Sir,
already seen this method of initializing.
yes,
Right?
sir. Yes, sir. Sir, will it make any difference in efficiency if we write them inside the braces and assign it?
Inside the braces means?
Like where we wrote the cout seat or and line.
But that is not initialization, right? That will be then become assignment. So initialization means that you have to write it before the body of the C. You remember we were also having this discussion about lifetime, right? So initialization is happening before the lifetime has started. Okay, the lifetime has started at this point. Clear?
Yes.
Okay. Okay. So okay. So now you see this particular so again we are defining the string class. So look at the program at the right. Okay, so we are defining this string class. Okay, and we have the we have the so it has a strings like cat star str, which is the pointer to the string and size. Okay, and now what we are doing is we are passing a C string to this particular string type. Okay. So basically you have you pass the character pointer, the C string. Okay. And then you initialize this str using str dup here. Okay. And len using str len here. Okay. And then you you go ahead with this. Okay, so this is a common way of constructing let's say this particular string type that you have created. Okay, and yeah, so you also have the destructor. Note that here you have to use free because this strdup function uses malloc. Okay, so okay, so and then you can create basically yeah, so string s is equal to partha. Okay, and now this basically the constructor will be called here because this is a initialization, right? Okay, so the constructor will be called, so you can see seater partha 6 is getting printed. Okay, and then again if you print it will also print the string. Okay, which is using basically this particular print method, and then the destructor will be called. Okay, so this is fine. Okay, now you look at the same program, the program on the right hand side that we showed in the previous slide. Okay, with just this len and str swapped. Okay, so what is going on here? So basically we are doing the same thing. So we are initializing str using strdup and len using str len. Okay, so everything else remains the same, only the data members have been reversed. Okay, now okay, now what happens, you see in this particular case, okay, and then you initialize so you basically create this this particular yeah, so you okay, so there is another, yeah, okay, so actually there is another difference here. Okay, so not difference from the previous program, but here one thing you should note is that we are taking the str length not of s here, okay, but of this str, okay, for initializing len. Okay, now, so when we try to initialize this string s here, okay, we get a exception in Visual Studio. So if you try to run it in Linux, you will get some sort of a segmentation fault. Okay. Okay. Now, what has happened actually? So can someone say why this particular error will come?
So first length, the len underscore should be initialized, sir, for which the length of the variable str underscore should be known. But str underscore is only initialized after len is initialized.
Right, right. So you see in the previous thing, the str was first initialized and then length was initialized. Okay, because str appeared first and length appeared next. Okay, here that is not the case. Okay, so that is why so even though you are actually calling this strlen later in the initialization list, but this initialization, this strlen gets called before assigning str underscore to this, because the order here has changed. Okay, that is why you get a error. Okay, so so this is so this is a situation where basically, for no apparent reason, so you may just change the order in which the data members appear, and the earlier program was running fine. This program will stop, not run. Okay, so so you have to be careful. Okay, so so one suggestion can be that you should have a consistent, so the thing you should follow is that you should make sure that whenever you are initialization of one particular data member is dependent on another initialization of another data member, you should sort of ensure that they happen in the correct order. Okay, and so my suggestion is that you keep the order of definition of members and the order of initialization of members the same. Okay, you should, I mean, it's a good programming practice to do that. Okay. Okay, so this is one example where
Sir,
yes.
sir, can you please once move to the previous slide?
Yes.
Sir, in the 2 to 2, 3 example, sir.
2,3 example. Okay.
Yes, sir. Sir, here we are sending 2, 3 and the variables order means the values are going perfect, like M1 is getting 2 and M2 is getting 3.
Right.
But the order of initialization is different.
Right.
So, sir, we can also do here, like in the string and the length example. First, we send string, and then we are setting the length.
That is what you are doing. See, so this is what we are trying to say here, right? That first you are, first you are setting string. So when you are writing the initialization, you are writing first string and then you are writing length. You can see this?
Yes, sir.
Right? But the compiler gives you no guarantee that this is the order in which things will be done. Rather, the order in which things will be done is initialization for length will appear first and then string.
Okay. So that means the initialization of length first is giving error.
Initialization of length first is giving error.
Okay, okay, sir, got it.
And sir, here while initializing str, if we directly pass s, will it cause some error, sir?
No, that will not pass. So you mean like initialization of length, right?
No,
So
sir,
what is-
initialization of str. Like we are doing str dup, then s.
Okay. So what can someone tell what will be the problem if we simply just passed str to this?
Sir,
So
not str. We will pass directly s.
yeah, directly.
Changes in S will be reflected in str.
Yes, yes. So they will simply see S is a character array, right?
Yes,
You
sir.
see S is a char star. Okay, so it is pointing to a character array. So the same character array will be also used to this, but for this string. Instead of creating a new
So, sir, we
string,
have to explicitly allocate new space to this.
right? Okay. Okay.
So, can you once go to the previous slide?
Yes.
Sir, there you have written uses malloc. So, where will the malloc be used?
strdup internally uses malloc.
Okay, str2. Okay, sir.
Okay. So that is why in the destructor you have to use free. So you could have also
Yes,
done it this way, that you could have said, you could have used new here, okay, new with strlen, and then you could have also done an initialization here. Okay, so that also could have been done.
Yes, sir.
Clear? So in that case, you could have used delete.
Sir?
Yes.
So in this, we are initializing str and len by using the format str and the parenthesis strdup. Instead of that, we can also initialize str underscore by keeping them in the curly braces. Like we have written cout seater print, right? In that function, in that block of code, we can just simply write str equal to strdup s and len underscore equal to strlen str.
Yes, yes, but we had this discussion actually. In that case, it will not be called initialization, but assignment.
Okay, so but that will be following the order, right? Because we are
That will
separating
be
them
following
by
yes,
semicolon.
yes, you are right.
Okay, yeah,
That will
yes.
be following the order.
Okay, sir.
Okay.
Yes, sir.
Okay. Okay, so yeah, so there are some more examples. So what we will do, we will, we will skip these examples. So we have put this example, so the slides will be uploaded. So please look at some of these other examples, okay? And you can try to figure out what is the, what is the lifetime, what happens before what, and so on and so forth. Many, these kind of examples are there for object creation, okay? So, okay. Okay, so now we move to another interesting concept, which is called the copy constructor. Okay, so so you see, okay, so let's say we have this complex class. You remember the complex has two doubles, okay, and you can initialize complex like this, that you can basically say 4.2, 5.9, something like this, okay. uh, or you can also do this complex C1 within bracket 4.2 and 5.9. Okay, this also works. Okay, and this this invokes the constructor. We know what is the signature of the constructor. So the constructor will be something like complex colon complex and then double double, right? So this will be the signature of the constructor in this case. Okay, in this case. Okay, now suppose, I mean, in many programming languages, or in many cases, you will see that it is only logical that you should be able to construct a complex object C2 using another complex object C1, let's say. Okay, so notice the difference. Here you are passing the real and the imaginary component. Here you are passing the other object itself. Okay, so then what will happen? Okay, so suppose you want to do something like that. So which constructor will be called? Okay, so the answer to this is that in this particular case, the copy constructor will be called. Okay, so yeah, or you can also initialize it like this, right? C2 is equal to C1. Again, this is a initialization. Okay, so in this case, which constructor will be called? Okay, the answer is the copy constructor will be called. Okay. Now, what is the copy constructor? So copy constructor will then have a prototype something like this. You see, this is complex colon complex and then const complex ampersand. Okay, so this is the prototype of a copy constructor. Okay. Okay. Now, so let us see this complex class. Okay, so let us come to this complex class. You have the real and the imaginary components. Okay.
Professor, can you show the assignment operation again? Because I have a question regarding that. So the second statement, complex C2 equal to C1. So I'm not sure if the copy constructor will be called in that case, because according to C++ like 17 standards, there's something called copy elision, which basically elides this equals operator and directly invokes whatever constructor is available.
So you are talking about C++ 11, right?
I think, yeah, okay. C++ 17 introduced copy elision.
Yeah. So 17. Okay. So we are talking about, yeah. So this is good point actually. So the discussion that we are having here, okay, we are having discussion on C++ 98 or you can say C++ 03. Okay. So there are many things. So not many things. There are some things which have been changed like this. So that is the other thing. Okay. So certain. Yeah, so there are many things which have been added. So we are not discussing. So for the purpose of this discussion, we will follow the C++ 98 standard. Okay.
Okay, Professor.
Okay. Okay. So now you see this particular. Yeah. So you so here you see this. So the first one is the constructor. Okay, so you can see that you have this complex. Yeah, so you have this real and imaginary components which are being passed. Okay, so this is the constructor. Okay, now the second one is the copy constructor. Okay, so yeah, so okay, so you can see the actual usage. So basically you are passing a reference, okay, to object of type complex, okay, and you are passing I mean you are passing in the it of type const. Okay, so basically the idea is that inside the copy constructor you should not be able to change the original object. Okay.
Sir, will there be any problem if we don't pass by reference, only pass const complex C?
So we'll come to that in a minute. Okay, so if we don't pass reference, what will happen? Okay, just hold on to it for 5 minutes. Okay. Okay, so okay, so this is here, and then you have the other functions. So you have the destructor as usual. You have a function that calculates the norm, and you have also the function that prints. Okay, now you see you are initializing these complex objects. So the first one is basically you are initializing using two doubles, the real and the imaginary component. Okay, second one you are initializing C2. You are initializing using just C1. And the third one you are initializing just normally, okay, and then you are printing all. So first you see the order of the output. So so first the complex constructor is getting called, okay, and it is printing everything. Okay, so it is printing you know the print, it is printing the complex number as well as the norm. Okay, then second time the copy constructor is getting called. Okay, and third time also the copy constructor is getting called. So this is so yeah, okay, so this is the behavior. Okay, and then of course you are printing them. Okay, and then the destructor is getting called in the reverse order as we have discussed already. Okay, okay, so I think this is clear. Okay. Okay, so now the question is where, yes.
So what if a class has an array as a member?
We'll come to that. We'll. I think in a minute we'll have a. Okay. I mean, but nothing changes much. I mean, what is your question really? I mean,
So what if a class has an array of size, a fixed size, say 5 as a member, which is
yes,
already initialized?
which is already initialized. So
Yes.
I mean, why would anything change in terms of the copy constructor?
Sir, cause here we are passing, like when an array is passed to a function, only the pointer to the first element will be passed, right?
No. In you are saying in case of copy constructor, right? So you are passing a reference of another object of the same type.
Professor, I couldn't understand his question.
I think what he is asking is that should we are we simply passing the passing the first I mean, so if it has an array, are we passing the pointer to the first address? That is the question, right?
Yes, sir.
So we are not passing the, so let's say, if this was like int a5 or something like that, instead of double re and im, it was int a within square brackets 5. Okay, we are not, I mean, conceptually, I mean, value wise the two addresses may be same. Okay, don't go into that, but conceptually we are not passing this a's address, okay, to the copy constructor. We are passing the address or the reference of an object of type whatever this complex. Is this clear?
Yes, sir. Sir, also, is this copy constructor a default one, or else we have to initialize it every time?
So there is a default copy constructor, so we'll come to that. Okay. Okay, so not default but free copy constructor. There's no default thing, but there's a free copy constructor that is given by the compiler. Okay. Okay, so let us get into this function call. So what are the cases where copy constructor will be used? Okay. So now you see in C++, there are many function call mechanisms, right? So the first one is call by reference. Okay. In this case, what happens? So this is when the formal parameter is actually reference parameter, right? So then a reference to the actual parameter, okay, is passed as a formal parameter. Okay, so in this case, there will be no copy or copy constructor will not be invoked. Okay, so there is no copy happening here, right? Only the reference is being passed. Okay, and similarly with a return by reference. Okay, but when you are passing objects using the call by value method, okay, basically semantics wise, the way C++ looks at it is that the object, the object which is I mean the actual parameter is being copied to the formal parameter, right? So for built-in types, it will actually be copied. Okay, so hence in this particular case, the copy constructor will be invoked. Okay, and similarly, when you are returning objects by value, okay, again, the object, in the local stack frame of the function, okay, needs to be copied to the object to which, let's say, this is assigned to, right? Okay. So again, in this particular case, the copy constructor needs to be invoked. Okay. Okay. Now, okay. Okay, so yeah, so basically copy constructor is needed for initializing data members of a UDT, right? So from an existing value, okay, user defined data type. Okay, so I think this idea is clear. So we did not go into a detail of what is a user defined data type, but you can think of complex as a user defined data type. Okay. 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 Yeah. So this is a situation where we are sort of doing a call by value. Okay. So this particular function display is taking an object which is cparam of type complex. Okay. And you have the usual copy constructor which is printing copy seater. Okay. And in the main, you are first creating the object, okay, C, and then you're calling display C. Okay. So here you can see first the constructor is getting called, which is basically creating this object C. Then the copy constructor is getting called, which is actually copying C to this formal parameter C param. Okay. And then this C param is actually so inside the display C param.print is getting called. Okay, so that is what is getting printed here. Okay, and then of course so then this particular C param is getting destroyed first. Okay, and then when the function display exits, and then finally when the main function exits, this object C is getting destroyed. So this destructor also gets called twice. Clear? Okay. Okay, so now we come to this question that how can we define copy constructors? Okay, so the first one we have already discussed that, if you are defining a copy constructor for a class, my class, let's say, okay, so your prototype should be something like this: const my class ampersand other. Okay, okay, you can also have my class ampersand other. Okay, the problem here is that inside the copy constructor you may inadvertently change the original object. Okay, because you are passing by reference. Okay, and so you have the reference to the original object. Okay, and you may inadvertently change. Okay, so this is not recommended, but it is possible to do it this way. Okay. Another thing is to use the keyword volatile here. Okay, so as you know, we already discussed. Basically, this will be very important when if you want to discourage some sort of an optimization. Okay, basically, in situations where this other may be changed outside the program. Okay, so this object other that you are using to actually initialize the or that you're copying from can be accessed or can be modified in a manner which is outside, the compiler cannot understand. Okay, so but these are rare. Okay, now if you are passing a pointer to, let's say, the other object, okay, this is not considered by the compiler as a copy constructor. Okay, it can be, so this method can be used to create copies of the object. Okay, so you can simply create from from another object, but this will not be considered as copy constructor. Rather, here basically the when creating when you are creating this particular object, okay, you have to pass a reference to another. So this is like a normal constructor. So you can pass, sorry, not reference, but pointer to another object of the same type. Okay, so this will be treated as a constructor, but not as a copy constructor. Okay, and the last is the question that was asked: what if I simply pass my class other? So I just pass, yeah. So if I just pass the other also by value to the copy constructor itself. Okay. Okay. Now this will result. So what will happen in this case, right? So you see that the compiler notices that you are providing a copy constructor. Okay. And now, and as you remember that when you are passing, object by value to another function, okay, the copy constructor is invoked. Okay, so in this case, in order to pass this value other to the copy constructor, the same copy constructor will be invoked. Clear? So this will result in a infinite recursive call. Okay, hence you cannot create a copy constructor like this. Okay, clear? So in summary, neither call by pointer nor call by value can be used for copy constructor. Okay, only call by reference can be used for copy constructor, for defining copy constructor. Okay.
Sir,
Yes.
sir, when we call by value, then what constructor will this constructor copy itself? It means like my class other will copy what into it?
See, as you know, so this my class, this copy constructor is a function, is a member function that we are defining, right? Right. So this member function is getting a parameter by value in this particular case. Okay, so this other will again invoke the same copy constructor, which is the name of the copy constructor is again my class. Okay. Okay. So this it will again call the same copy constructor. Okay. That is why it will go into recursion. Does that answer your question?
Yes, sir, it will call the same, but what parameter will it pass now to that new copy constructor?
Other.
So means itself only, right?
Yes. No. Other is not itself, right? Itself is why should other be itself? Other is the, so come here. Okay. So for example, or let me come here, right? So here you are trying to create this C2. Okay. So the other is actually C1. Does this make sense?
Yes, sir, but like when we say my class other means inside that parameter, then again it will call another copy constructor. So what will be the other for that object?
For that also, there is no other object. No, so see, there are two things, right? So one is that, see, there is this object C1. You look at this program. Okay, so there is this object C1. Okay, now this C1 is getting passed as reference in this case to this C, which is the copy constructor parameter, which is the formal parameter here. Clear? Suppose it was not, you did not use a reference here, then this C1 will have to be copied to this parameter C. Clear? And then that copying process will again call this particular function complex. I mean, this particular function again. Am I making sense here? So the parameter will still be C1, okay? But the formal parameter, I mean, the process of copying parameter to formal parameter will result in a result in an infinite loop. Okay. Okay. So yeah, we can discuss after the class also. Huh? So just think about it. Okay. Okay, so again, these are some other examples. Let me skip, so you please go through this, and if you have any questions, we can discuss in the next class. Okay, so yeah, so like we said, so if you don't provide a copy constructor, the compiler supplies a free copy constructor. Okay, and this particular free copy constructor, what it does is it does a bit by bit copy. Okay, so you know your object, so your class has some members. Okay, and the members are members can be like, so there's a there's a bit layout for the class. Okay, so the free copy constructor simply copies bit by bit the object. Let's say you are copying from C1 to C2. It will copy every bit of C1 exactly into C2. So this is what the free copy constructor does. Okay.
Professor, I have a question. So, for example, if a class has another class object embedded inside it. For example, if complex has like a class that says some real class REAL, which has its own copy constructor. Now, let's say the default constructor for we don't define a copy constructor for complex. What will happen in that case? Will the constructor for real be called the case of the default copy constructor of complex?
No, it will be bit copy. So bit copy doesn't call the constructor of the objects inside that, right? So that object will be copied bit by bit. Okay, so exact memory layout of the other object will be copied to this object. That's it. So we'll just come to it. Just give me 1 minute. Okay, we'll explain with an example. Okay. Okay. So okay, so this is the situation where where you see we have basically, if we so if we just comment out the copy constructor, okay, which we have done in this particular case, okay, then if we have the copy constructor, the left thing is what is printed. If you don't have the copy constructor, the right hand side is what is printed. So the compiler actually supplies the copy constructor. So there is no message about the copy constructor that will be printed. Okay, but the other things in this particular case will go through. And as you can see, the destructor will be called twice only. So that sort of confirms that this particular object was again created. And that constructor was obviously not called the original constructor, and so the default copy constructor was instead called. Okay, yeah, so you can just look at this. Okay, yeah, so now let us see what is going on in this particular program. Okay. Okay, so you are so this is our string object. Okay, and we are providing the constructor. Okay, and we are also providing the copy constructor here. So the copy constructor here, if you look at this, it is doing basically what the constructor is doing. So okay, so it is taking this input string, and then it is doing a str_dupe of the string of this particular str_ of s. which is the input string, okay, and also assigning the length, okay. So this is what is called, so notice that it is this str_dup is actually allocating new memory for the current str underscore, okay. Okay, so this particular way of copying is called deep copy, okay. So in this case, basically you see there are two fields which are there, okay, and one of the fields is a pointer, okay, and yeah, so if you just do a bit by bit copy here, okay, so if you don't do a deep copy here, what will happen? Your so for the new so the new object to which you are copying things, okay, your so it will have its own so if you don't do a deep copy like this, okay, your the so it will point to the original array, okay, it will point to the original array which was there in the original object, okay. So in this case, let us look at this particular program. So so we have a string s, okay, and then we are printing s, and then we are calling this str_upper, okay, and we are calling this by value, so the copy constructor is getting called, okay. Now here, after after the toUpper has been called, so the toUpper basically makes everything uppercase, okay. Okay, you say that yeah, so you print and then you return, okay. So you see after toUpper was called, everything was in uppercase, okay. But when you come back and print it again here using s.print, okay, the string, original string is returned, okay. So this is safe, okay. So there is so this behavior is exactly as though you are passing this string a by value, okay. But if you were not doing a deep copy here, you would have seen the uppercase partha here, okay. Okay, now look at so this is an interesting example. You look at this particular example, same I mean the same program that we saw in the previous slide, okay, but now we have removed the copy constructor, okay. So what it is using is the free copy constructor, okay. So then it is doing a bit by bit copy, okay, and since it is doing a bit by bit copy, what will happen? The original string is pointed to, and then it comes back, okay. So here you see what happens. The initial so for s.print, partha gets printed. When you go to inside the str_upper function, again the uppercase partha gets printed, okay. Now when you come back, this results in a problem, okay. So it can either result in a some garbage being printed, or it can result in a segmentation fault, okay. Now what is the reason behind this, okay. So the reason behind this is that your so when you when this s is when there is a call by value performed here, okay, str_upper, okay, this formal parameter a, I mean this s gets copied to the formal parameter a, but now in this case there is a bit copy, okay. So there's a bit by bit copy. So this string a, what kind of object is this? So this is a new string, but it is the str is still pointing to the same array as s, okay. So a.str is pointing to the same array s right now, okay. Now inside whatever happens, Now, when it returns from here, this particular element A must be destroyed. Okay. Now the destructor actually calls a free on the str of this particular object. Okay. So the destructor for this object A will actually free up the memory of the object S. Okay. And hence, instead of coming back and printing, capital. So if this freeing was not done, after coming back, you would have seen here the capital Partha. Okay. But instead, what you see here is garbage, or you can also get a program crash simply because the memory has been freed by the destructor. Clear? Okay. Okay.
Sir,
So, yes.
sir, if it is not getting copied, how can it destruct? Because the scope is different, right? As you said before, the object will get destroyed when it came out of its scope.
No,
But
no. So the object is getting created. See, this when we are calling this str2 upper, okay, the current actual parameter S, okay, is getting copied to this formal parameter A. Agreed? So first this object A will be created as in basically the memory will be allocated for this object A inside the stack for this str2 upper function, stack frame of this. Okay. Then the contents of this object S will be copied there. So what are the contents? The pointer value and the len. Okay. So now this A is this string object. It's a new string object. It's not same as S, but it is pointing to the same array. The str pointer is pointing to the same array as S. Clear?
yes, sir. But when it deletes, will it delete the only pointing thing, or will it also? I mean,
It will
pointer.
delete the object S, object A. So
It will also remove the data in that.
Yeah, so deletion, what does deletion involve, right? So it will first call the destructor, okay, and then it will unallocate memory for all the object itself, so all the variables, member variables which are defined inside the object, right? So destructor does free str. Now str is pointing to the same array as s.str. So that particular array will be freed first, then this object A will be destroyed.
How is that 6 getting printed?
How is?
The 6.
Oh, because you see this new object, okay? So this old object S, okay? What does it now have? It has, so it has a pointer str to the unallocated memory and
Yes,
the
I got
length.
it. We only lost the pointer, not the other one.
No, the pointer is also there. The array that it is pointing to, you lost. Clear?
Yes, yes, sir.
Okay. Okay. Now you see. Okay. Now, okay. Today. Okay. So we are, I think, over time. Okay. So this we will start from tomorrow with this copy assignment operator. Okay. Any questions?
Sir, could you please go to the portion where you said that copying by value would cause an infinite loop?
Yes.
Sir, that way of defining the function, is it not legal, or is it? I mean, if I write it that way, it will cause an infinite loop. I didn't get that.
Yeah, okay. So if I mean, yeah, so what is the exact error? So it will be detected. So yeah, so I don't know the exact error message you will get, but it will be detected at the compile time.
Okay, sir. So it's not legal to write it that way.
It's not legal to write it that way. Yeah.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Okay then. So thank you very much. So see you in 1 hour.